put the thing which is inside the bracket, log 10x, log 10 experiments, 8 log x, greater than, it should be greater than 0, right? As the
Yes,
domain. Then how
yes.
will we solve that inequality?
Okay, so you don't know how to solve inequality.
No, I
I
know,
mean, I
but
want.
I can't able to solve this inequality, which we will get.
Okay, okay, okay. Okay, so let us solve it together. You are able to see the screen, right?
Yes, ma'am.
Okay. So, okay, we will do it step by step. So basically, this step all of you already know, right? That this portion should be greater than 0 in order to define this log first, right? Plus 15. This should be greater than 0, right? So, can we factorize this thing? If just take p equals to log 10x for simplicity, okay? Then our new equation is p square minus 8p plus 15.
Yes,
Okay,
ma'am. Now understood. Yes, ma'am.
okay. So this is basically greater than 0, right? So can I factorize this? Minus 5 minus 3, right?
Yes, ma'am.
Minus 5p minus 3p.
Minus 3p.
This is greater than 0, right? So then it will be p minus 3, p minus 5 greater than 0, right?
Ma'am, somehow
Yes.
it's look like a quadratic equation.
Yeah, this is a quadratic equation. And this is the key if you have this type of inequality. So it can be greater than 0, it can be less than 0. Okay. Your first target should be you should like try to factorize this quadratic equation. Okay. Then you can conclude. So we have two factor and multiplication of these two factor is greater than 0, right? That means we have two type of possibilities. Either these two factor can be less than 0 individually or they can be greater than 0 individually, right? Then we will get basically positive, positive, positive and negative, negative, positive, right? So we have two different possibility. This 2 will be greater than 0 or this two will be less than 0 together, right? This step is clear?
Yes, ma'am.
Yeah. And what if this is instead of the uh, greater than sign, if we had a less than sign, then what should be the conclusion?
Then it will be between these 3 and 5.
Yes, right. That means it should be greater than either like one factor will be greater than 0 and one factor will be less than 0, right?
Less than
So we
0.
will again get two different cases, right? So from this portion, we will get that p is greater than 3 and p is greater than 5. So if we take p greater than 5, then automatically this will hold, right? Right? So we will take p is greater than 5, this portion. Did you get the logic why we are taking p greater than 5?
We are taking the common part.
Yeah, we are taking the common part. Yes. So if p is greater than 5, then automatically it is greater than 3, right? Similarly, here we will take p is less than 3. So if p is less than 3, then it will be automatically less than 5, right? Then we have p is greater than 5 and p is less than 3. So we will then get, so our p is log 10x, right? So log 10x will be greater than 5. It will imply x will be greater than 10 power 5, right?
Yes, ma'am.
And yes, and from this equation we will get x will be less than 10 power 3, right? So what will be the interval then? This portion, right? Because if we take something less than 0, then this log will not be defined. So we have to take x greater than 0, right? So x will be greater than 0, less than 10 cube, and union x will be greater than 10 power 5 up to infinity. So this is the region. Is it now clear?
Yes, ma'am.
Okay, so it's clear to everybody, right?
Yes, ma'am.
Okay.
Ma'am, why are we taking 0 to 10 to the power 3?
Because if we take something less than 0, then this log will not be defined, right? We have to also define this log, right? For the same x, log 10x. But if there is something negative, then we cannot define the log, right?
Okay, yes,
Even
ma'am.
for 0, we cannot define log, right? So we have to take something which is positive, right?
Yes, ma'am.
Yeah. Okay. Is
Hello,
it
ma'am.
is it now? Uh-huh.
Is recording available for this?
Yes. So if you want this session, you will get the live streaming. Also, you have the recorded version of your problem solution, assignment problem solutions. Okay. So
Ma'am, this session is only for activity question solving or concept
uh,
clearing session.
no. This is summary session is already done, right? So this is
Somebody
the
already
open
done.
session. Yeah, this is the open session. If you have any problem related doubt or any doubt, you can ask. Okay.
Or
Ma'am, I
you will solve the activity questions today.
I will solve all the question. I mean, I will solve your doubts. I will basically here to clear your doubts. Okay. It can be related to your activity question. It can be practice assignment. It can be anything. Okay.
ma'am,
It
I
can
want
be
summary
related to
summary
concept.
recorded lecture.
A summary recorded lecture you can find in the official channel. The live it has been live streaming, I guess. So just go to the official YouTube channel, and then you can find the summary session there. Okay.
Okay.
So in this session, basically, I will cover all the doubts. It can be related to the assignment solution, activity or practice. And if you have any concept related doubt too, then I will try to clear it. Okay. Okay. So what is the next issue?
Question number 5.
Okay. So what is the problem with question number 5? This is the same thing, right? Again, we have to take this portion is like greater than 0. So did you try it?
No, ma'am, I can't able to understand this question properly.
Okay, so domain
Where to
means
start
this
from?
should be greater than 0. Okay. So this is the general thing. When you have log of something, we know that the domain for log function is 0 to infinity, right?
Yes,
Log
ma'am.
x, domain of log x is 0 to infinity. But if we have some fx instead of x, that means log of some function of x, then we have to take this type of value for which it will give the result as greater than 0. Okay. So basically, you have to take this function as greater than 0 always. Okay. When the question is like define the domain, then just take this middle portion as greater than 0. Okay. Just take it greater than 0. Then it will imply x e power 3x minus 27x less than 0. Okay. Now can you solve it? Mhm. You can take x as common, e power 3x minus 27 less than 0. Then you have to do similar type of things. Can you solve it now?
Ma'am, the X will get okay. This is no, ma'am.
You can
Can you please
take x as
explain
common.
the whole question?
Okay, so up to this step, it's clear, right?
Yes, ma'am.
Okay. Then again, we can do similar type of things. That means because this 2 multiplication is negative, so we have 2 different possibilities, right? Either x greater than 0 and this factor less than 0, then the multiplication will be less than 0, right? Or x less than 0 and this factor is greater than 0. This step is clear?
Yes, ma'am.
Okay. So from here, what can we imply? E power 3x will be less than 27, right? 3x will be less than ln 27, right? What is 27? 3 cube, right?
Yes, ma'am.
So this will be 3x less than 3 into ln 3. Is it clear? Hence, x will be less than ln 3. So x is greater than 0 and x is less than ln 3. That means 0 to ln 3. Okay. And from here, we will get x is less than 0 and x is greater than ln 3. But is this possible together?
No,
This is
ma'am.
not possible, right? So this case, we will not consider this case. We will consider this case only because this is not possible, right? So we will not consider this case. So this is the domain 0 to ln 3. Is it clear now?
Yes, ma'am.
So this is something general. Whenever it can be in the exam or it can be for any example, whenever you if you have any logarithmic function of some function like logarithmic of fn, okay, in that case you have to take fx greater than 0, then just solve the equation. Okay, solve the equation and make this type of observation. If you will get an inequality, right, then just try to factorize that equation. Okay, then you can get either it's greater than 0 or less than 0. Then just do this type of observation, and from this type of observation you can get the domain. Okay, so this is this holds for any logarithmic equation. Okay, is
Yes,
it
ma'am.
clear?
Ma'am,
Yeah.
ma'am, some confusion in it. Ma'am, why did you take, ma'am, a natural logarithm? Ma'am, we can take, ma'am, common logarithm also for, ma'am,
Okay.
ln 27.
See, yeah, you can take common logarithm also, but it depends. I mean, what do you want to do? Here, I wanted to cancel that exponential.
Ma'am, you're not audible.
Or some a power 3x, then we had to take logarithmic based a. Okay, is it clear?
Okay, ma'am, understood.
Yeah, we wanted to cancel e. Okay, that's why we took the base as e. Okay, which is your natural logarithmic. Okay, if there
Okay,
was
ma'am.
some any other exponent, then in that case we had to take logarithmic base as this particular number. Okay. Okay, so is there any other doubt in 6.1?
Ma'am, my doubt is in question number 4, which states, ma'am, there should be no function of this log.
Why? Okay, so so basically when it will not be defined, like you have to confine the cases when this portion, I mean logarithmic of x square plus 1 by x square minus 1, this should be when this is less than 0, then we can say that there is no function in this form, right? So I'm giving you a hint for this. Just take this portion x square plus 1 by x square minus 1 as less than 0. Okay, then just solve it in similar manner. Then you will get some values of x. Okay. Also, when x equals to -1,
minus 1 or plus 1.
yeah. So -1 and +1, then this will not be defined, right? Because then x square -1, this portion will be 0. So this is not defined, right? So just solve this, then you will get like, just take it less equals to 0, okay? This portion, x square plus 1 by x square minus 1. Then you can find some values of x, and this will be the interval, okay?
Okay, ma'am, understood. Thank you, ma'am.
Okay. What about 6.2? Is there any doubt in 6.2?
It's minus infinity to 2, right?
Which one?
Ma'am,
Yes.
ma'am, in 6.1 fourth question just now which you have discussed, I'm getting the domain of the function as minus infinity to open bracket -1 union open bracket 1 to infinity. So the question is asked such that for which of the values no function is valid. So
Yes.
A, B,
That
C, D
means
should be the answer,
you have
right?
to take the opposite of the domain.
Yes, ma'am. If I do that, then I'm getting A, B, C, D, right?
What ABCD?
I think it is, answer is B. Answer
Yeah,
is
the answer is B. Yes.
answer is B, no?
Yes.
Ma'am, we should not include -1, right? In the domain. As
Yes.
per then
You have to find the anti-domain. I mean domain complement.
Anti-domain, yeah.
First find the domain, then just do the complement. Okay. So that you can conclude. In the set of a function for which this is not defined, we have to find the anti-domain. Okay.
Okay, ma'am. I thought we have to conclude. I'm substituting even like even option A is not in the domain, right? Because it's including -1. So I thought it is correct.
No.
Okay, ma'am. Okay. I understood.
Yeah. Just calculate the domain and then just calculate the complement of the domain. So we have to find the set in which this function is not defined. That means domain complement. Okay. Is it now clear?
Yes, ma'am. Yeah, ma'am.
Okay. So what about 6.2? Is there any doubt in 6.2?
Ma'am, question number 3.
Okay. So yes, what is the doubt here? In which part are you facing the difficulty?
Domain part, ma'am.
Okay, so you all of you are done with like f is 1 or it has an inverse and
Yes, ma'am.
asymptote. These things are
Yes,
fine,
ma'am.
right?
Done. Yes, ma'am.
Okay, so you are facing problem with the domain part only, right?
Yes, ma'am. Because in logarithm, ma'am, domain of x would be 0 from 0 to infinity. And this, ma'am, option is given, but this is wrong.
Okay. No. See. You have to define this logarithmic, right? We will go always step by step. That means this portion should be greater than 0, right? In order to define the last logarithmic. Okay. We will always follow this step while calculating the domain of some logarithmic function. Okay. We will take the last logarithmic as our logarithmic function, and whatever is in the middle, we will take this as greater than 0. Okay. Yeah. So if logarithmic of logarithmic of something is greater than 0, that means what can we conclude about it? I mean, at the point 1, we get the logarithmic value as 0, right? Logarithmic of something like based at something at 1 is 0, right? So from here, we can
Yes,
conclude
ma'am.
that logarithm 2 of x, this should be greater than 1, right?
Yes, ma'am.
Yeah. And from here, what can we conclude? Just take 2 here and 2 here. Okay. Then this term will be cancelled out. So x will be 2 power 1. That means 2. Okay. So the domain will be 2 to infinity. Is it clear?
Okay, ma'am. Okay, ma'am. Understood.
Ma'am,
Yeah.
why not D option is right, ma'am?
Okay. So you just have to calculate the asymptote. Is it so? I mean, if x equals to 8 is asymptote, then you should get some infinity or minus infinity as extending to 8. So we can take extending to yes.
Can you explain asymptote part? Actually, I'm not get that.
Ma'am, it's asymptote on 2, I think.
Yes, maybe we can calculate it. I mean, okay. So
Ma'am, could you clear about asymptote part? How to calculate, ma'am?
yeah, in the last lecture also I have told you, na, when you want to calculate the asymptote, you have to choose the limit as extends to infinity or extends to minus infinity. If you can find something like some positive thing, I mean some finite thing, then this is the asymptote. Okay. Otherwise, we cannot say anything. Here, if extending to 2, okay, then this portion will be tending to 1, right?
1, ma'am. Then the next one will be tending to 0. Okay. Okay.
Yeah.
Okay. We have to
Then
do
this
trial and error, ma'am.
portion,
Like somewhat like that.
no, not trial and error. See, this is basic observation that the boundary points, you have to check for the boundary points if you have the exponential or logarithmic function. So for exponential function, I have already told in the last lecture that for exponential function, you will always find a vertical asymptote. Okay. So vertical asymptote means sorry. For exponential function, we will find a horizontal asymptote. Okay. So horizontal asymptote, how can you calculate? We just have to take extending to infinity or minus infinity, then you will find some finite value for y. Okay. And if you want to calculate vertical asymptote for logarithmic function, there is always a vertical asymptote. For calculating the vertical asymptote, you have to take the y function as tending to infinity or minus infinity. Okay. Okay. So if this function tending to infinity, then this is possible when x tending to infinity, right? And this function will be tending to minus infinity. This possible when x tending to 0. So basically this happens in the boundary points. Okay. So this is something general, whether it is exponential function or logarithmic function, you just have to check at the boundary points. Okay. Is it clear? My point is clear.
No, ma'am. About the logarithms, once again, could you the vertical asymptote one part?
Okay. So here, what was our domain? The domain was 2 to infinity, right? So we will check at the boundary points. That means when extending to infinity, we will find fx tending to infinity, right? And when extending to 0, we will find fx tending to minus infinity. Sorry, extending to 2, then fx tending to minus infinity. Okay.
Zero, right, ma'am? When extends to 2, the whole function gets 0, right?
By 0,
Right.
this portion will be tending to minus infinity, right? This portion will be tending to 0, hence the whole function will be tending to minus infinity. Okay. Okay.
No, ma'am. I'm like, I missed somewhere. One second, ma'am.
If x tending to 2, then this function will be tending to 1, right? Logarithmic of 2 of 2.
Yes, ma'am.
Then
Yeah.
the whole function will be tending to 0.
Yes, ma'am.
Then this function will be tending to minus infinity.
Oh, yeah. Okay. Yeah. Sorry. Yeah, I understood.
Okay. So we have to check the limit, but not at some random point. Just check the limit at boundary points. Okay. That is what I am saying. Okay.
Yes,
The
ma'am.
Is it fine?
options for this are f is 1 and 1 to 1 and f as inverse. These are the options which they gave.
What can you repeat?
The correct true options for this are f is 1 to 1 and f as inverse. These are the two options which they gave, which
Yeah.
are correct, satisfying. Yeah. So how do we explain that? F as inverse, how do we take f as inverse? Check for that.
Okay, so you can just simply, for this function, specifically we can say that like if we have invertible functions and just do the composition, then it will be invertible function. Okay, so we know that logarithmic function is invertible and the inverse is exponential function, right? So we are doing the composition of 3 invertible functions. So it will be again invertible function. Okay. Composition of invertible functions is invertible, and composition of 1 function is also 1 function. Is it clear?
Composition of 1 function is
1 and composition of invertible function is invertible.
okay, but where is the composition of the functions here? Are we looking at f of f?
Yeah, just for say you can take as f1 equals to f2 equals to f3 equals to logarithmic 2x. Okay. Then
Okay.
we're just composing f1 compose f2 compose f2 f3 here, right?
Hmm.
Yeah.
Right. Okay, understood.
Yeah. So this is, you can do up to n time. If you just compose n time some invertible function, then it will be invertible. Okay.
Ma'am, a small request. Could you write in 2 points about in a neat way so that I could copy in my notes about asymptotes, ma'am? Vertical, like just now you said for f of x value should be going to minus infinity to infinity. For horizontal, what is the thing? I'll just copy in my notes. Could you write it in a proper way?
Okay, this is not horizontal, this is vertical. So for
Yes, ma'am.
logarithmic function, you will always have a vertical asymptote. Okay. So your domain is 2 to infinity, right? This is a domain. And if you want to calculate the horizontal and in the vertical asymptote, you just check at the boundary points. Okay. So infinity we will not take. Okay.
Okay, ma'am.
Because infinity is not our concern. But we will take if there is any finite point, then we will collect it. So there is only one finite point, which is 2, right? And we can check when extending to 2, then this function will be tending to minus infinity. Is it clear?
Yes, ma'am. Yes, ma'am. Yeah.
Yeah.
Yes, ma'am.
Yeah. So that we can conclude x equals to 2 is the asymptote. That means particularly the vertical asymptote of f. Okay.
So, ma'am, for
If
log
it was not
x,
the case,
for a function
yeah.
log x, only log x, the asymptote is x is equal to 0.
Yeah, correct.
Okay, ma'am. Ma'am, for a power x, could you just give that hint, ma'am?
Okay. If you have a power x, in that case, you will get the something like that, na? The diagram. So in that case, we will not get any vertical asymptote because it will be something tending to infinity, this line, right? Correct?
Yes, ma'am. Yes, ma'am.
But we will get a horizontal asymptote, this line, right?
Yes, ma'am.
In that case, you just have to take extending to infinity or extending to minus infinity. Okay. Then for this value, we will find some value of y. And that value is the horizontal asymptote. Okay. That means if you have a power x as extending to infinity, this a power x will be tending to infinity, right? So this is not the case because we are getting infinity here. We want something finite. As x tending to minus infinity, we will get this tending to 0, right? So y
Yes, ma'am.
equals to 0 is the horizontal asymptote.
Okay, ma'am. Understood.
Yeah. Okay. So it's clear to all of you, right? The what asymptote type of thing for horizontal asymptote and for vertical asymptote. Is it clear to all of you?
Here we are taking log 2 x, right? The greater than 1.
Yeah.
So if I'm substituting x equal to 2 and it becomes 1, log 2
Yes.
of 2, and again
This
log
becomes 1.
2, log base
Log 2
2,
of 1 is this becomes 0.
uh-huh.
Log 2 of 1. This becomes 0, right? Then we will get 0
Yes.
here instead of this. So log 2 of 0. This is basically minus infinity, right? So when x tending to 2, this portion will be tending to 0 and this portion will be tending to minus infinity. Is it clear?
But log base 2, 0 is not a function, no?
Yeah, that is what we are taking tending to 0 now. We are not taking exactly equals to 0. We are taking this type of thing, open. Open means we are not taking the point directly. We are going close to the point.
Okay.
We are not putting 0 directly. We are taking some point which is very close to the point 0, which is tending to minus infinity.
Okay, okay.
That is why we introduce the limit system, na? Because sometimes we cannot put the point directly, but we can put some point which is really close to the point, and it is that close that we cannot calculate or we cannot imagine the points. So it is almost that point. It is almost 0, but it is not 0. That is what it is almost tending to minus infinity, but it is not exactly minus infinity. So there is a huge difference between tending to minus infinity and exactly minus infinity. Exactly minus infinity is something not defined because we cannot define infinity or minus infinity. But we can define something tending to infinity. This is some number which is really big. We don't know, so that we can define it as tending to minus infinity. This is a very small number. Okay. But exactly minus infinity we cannot define. That is why we cannot define log of 0, but we can define log of x, where x is tending to 0. That means x is very close to 0. Okay, that is why the domain is open interval 0. Open interval 0 means we can take all the points which is greater than 0, excluding the point 0. I mean, you cannot never, if you can never imagine what the point is. I mean, you can say it is some 0.00001, which is really close to 0. I can put 10 more 0 there, right? It will be more close to 0. You can put 100 more 0 there. So there is no, I mean, restriction, right? That is what we choose, this tending to 0 type of thing.
Okay.
Is it clear?
Yeah.
Yeah.
Ma'am, for a power x, a sort of example for horizontal asymptote, could you give an example where y is equal to not 0, like some y is equal to 2 or 3 value? Like, where will be the change coming? Once, could you give one example?
You can take some b plus a powered x, okay? Then we will just, in that case, this equation just got shifted with b. This b can be positive, this b can be negative. So in that case, if we take x tending to minus infinity, we will get y tending to b. Okay. So this is not 0.
Okay, ma'am. And yes, ma'am. Thank you.
Yeah. Okay. Okay. Any other doubts from your activity person? What about activity question 6.3?
Ma'am, first question. 1, 2, and 4.
I mean, what is the doubt with the first question? This should not be the doubt. I mean, what is the difficulty? Mm-hmm.
Ma'am, even I forgot. Like I did many days back. I just noted down. Sorry. No problem.
Okay,
You can skip
so
it.
yeah, can you try it again? If not, then I guess there is a recorded version also. So you can go through this. Just you have to calculate for the like composition of domain, like composition of function, and you have to calculate the domain. You know the range and domain for logarithmic function, and they have given the domain of f, right? So you know that how to calculate the domain of some composition function. I have covered it, right? Just 2 to 3 steps, right? Just
Okay, ma'am. Yeah.
try
Yes, ma'am.
to try to do in this way. What is the next doubt? What is
Second
the
question. Second question was my doubt, ma'am. I couldn't understand the question actually.
okay? So here the question is given, and you have to conclude about the options. Hmm. Okay, so if is one that can you you can conclude from the composition. Okay, so you can take three function x or you just one for one, like if f is increasing function, then clearly it is one, right? And about increasing, this is the general thing, like if you have a function, you just calculate the derivative. If the derivative is greater than 0, then the function is increasing. If the derivative is less than 0, then the function is decreasing. And if it is equals to 0, then the function is constant function. Okay, so if some function is increasing or decreasing, then the function is a one function. Okay, so this is one way. Uh, I would like if you can try it by your own. Okay, this is the hint. Just
Ma'am,
see the
once again, could you tell for increasing function, how did you do this
so
for
yeah,
this
you have
question?
the function ff. So let me write the result. So this is the function. If we will calculate the derivative of f, okay. So there are three type of chances. This can be greater than 0, the derivative at the domain, in the domain. If there are function which is neither increasing nor decreasing, right? So in that case, you will not find anything specific in in the domain. Okay, but if you can find something specific in the domain, in the whole domain, then you can conclude the function is increasing or decreasing or constant. Okay, this three are possibilities. So if this is greater than 0, then we will say this is increasing function. If the derivative is less than 0, then the function is decreasing. And if the derivative is equals to 0, then the function is constant function. Okay, so this is the result. So you can apply this result for any function. Then you can calculate whether it is increasing or not. Okay.
Okay, ma'am.
Yeah. And if a function is monotonic, that means either increasing or decreasing, then obviously it will be one function, right?
Yes, ma'am.
Yeah. Okay. So what about
Fourth question, ma'am.
so what is the problem in fourth question? You will get a quadratic equation upon solving it. I mean, you have e power something. Just take a logarithmic. Okay, I will let me solve it. So you have to solve it. So just do step by step. Okay. So what is your first target? You have to just cancel this e, right? For that, you have to take logarithmic base ID. That means natural logarithmic function. So we will take ln here and ln here. Okay. So we will then get x 4 powered x minus 2 powered x minus 12 equals to ln 1, which is equals to 0. Is it clear?
Yes, ma'am.
Yeah. Now just check the similarities. I mean, what can you do with these things? So we can write it as a quadratic equation, right? Whenever you have some equation like that, try to express it in a quadratic or cubic form if it is possible. Okay. So now you can get a quadratic equation. You can get p equals 2 power x. So you will get the quadratic equation, right? Now you can solve the quadratic equation. So what will be the value of p? Tell me. Just calculate it. You know the squaring root process and factoring process.
Yes, ma'am.
You can factor it with 4 and 3. Also, you can calculate it with Sridhar
4
Acharya
and
rule.
minus 3. 4 and minus 3.
4 and minus 3, right? So that means 2 power x equals to 4 and minus 3. But exponential function, is it possible for exponential function to give some negative number? What is the range of exponential function? It is always positive, right?
Yes, ma'am.
So minus 3 is not possible, right? That means there is no x for which 2 power x is minus 3, right? So minus 3 we will not take because the range is positive for exponential function. So we will take 2 power x equals to 4. 4 means 2 square. Then we will compare the exponent. So this will be x equals to 2. Then this option is the correct answer. Okay.
Yes, ma'am. Understood, ma'am.
So if you have this type of question, just solve it step by step, okay? And if you have this type of equation, just try to form a something. Most of the time, you may form a quadratic equation with the help of this type of thing. Just take p equals to exponential function or the logarithmic function, then you will get a quadratic equation or maybe some cubic equation. Then just solve equation. You know how to solve a quadratic or cubic equation. Then just try to factorize it or something like that. Then you can conclude. Okay. Is it clear so far?
Yes.
Okay. So what about 6.4?
Madam, video lecture they solved on problem I provided the chat box. Can you in this it is very big and difficult to find out the same numbers. Can you please? Is it possible to explain here? And I have two questions. This kind of problem will come. This kind of problem will come means it will take for half an hour. I think so. So maybe that also you can confirm. Maybe it is for the only for the understanding. Maybe we can work out, or this kind of problem maybe we can expect in the quiz also.
Okay, so some of the question you can expect in the quiz also, like the solving equation type of thing. This type of question will be in the question, maybe. So
Ma'am,
this
for
is
first question, if I'm taking a value 2, I'm getting the reverse also.
okay.
I'm having a small doubt in that. I
What
don't
is
remember the. Yeah, if I substitute m equal to 2, I'm getting even option C as right, I guess. I don't remember it. Many days back I solved it.
On which question you shared it?
What?
I shared to Samrita Das the
Okay,
chat
okay.
box. Madam, is it possible to open that your screen? So
Yeah, I
maybe.
can see one question. This is from SSC. I mean, this is
Yeah.
right. This one.
Yeah. Yes. Yes. I'm not able to see in your screen.
Uh,
So you want question also maybe
Where did you get the question?
and in the video lecture. In the video
Okay,
lecture,
okay.
yeah. So that is
you
very
just
big.
shared the question.
I'll sharing the question also, madam. 1 second. Yeah, I shared. It is explained in the video lecture, but the
You
numbers
can
when
share it to everyone so that everyone can see it.
Everyone, you can share it to everybody.
yeah, I'm sharing now.
Yeah. So what is the problem? I mean,
It's a question and so here what they explained, no. So I understood the steps, but the option one SSC they are calculating, no. That numbers the first step itself that 1.18 and plus 0.006. I don't know that numbers how they are arrived. I'm not able to understand actually. It's not coming actually the same number when I work out that issue problem.
They directly calculated and gives the answer.
You
yeah. Actually, I didn't solve it. Maybe it was made by something else. So I have to check it. I mean, thoroughly, I have to check it to make some comment. So better you can discuss it with your fellow mates, na, if there is someone who have already solved the question or who is getting the same value. Because I need to check it thoroughly, otherwise I cannot make any comment. So for that it will take some time, and this is the session
so
for
for
week 6 now.
fellow mates means this only the medium. So we are discussing. So
Okay, so you don't have any group or anything, any common group. You can form a common group now, like so that you can discuss some problem.
okay.
Yeah,
So
always. Please try to form a common group. You should discuss the problem. Yeah, you have the discourse too, no? You can share your
so
doubts.
any clarification that chat only I'll ask. So somebody will answer. So this is
Yeah.
very big. So that's why maybe um,
Yeah, also if I like try to see it, it will take some time, na? So I don't want to do this because this is for week 6. So I want to first clear all the week 6 doubt because this is from week 2 maybe.
no, it's
Uh,
week 6, madam. This one. This is in week 6 only.
oh, this is week 6. I
Ah,
thought it is from week 2
He
because
he
square.
solves the question directly. Like he follows some step and gives the answer directly because it is very long process and video is very short.
Okay.
So that's why.
I will just suggest you someone has sent some group link. Maybe you can check it if there is some student discussion. So you can discuss it first among yourself.
okay,
Then, if you are finding still difficulty and all of you are facing like problem with this solution, then I can see it. Okay.
okay.
Yeah. Yeah. So, is there any other doubts?
Ma'am, question number 3.
Yeah. Question 3. Okay. So, what is the problem here?
Ma'am, here how to count the number of solutions?
Okay. So, just calculate. Just solve the equation. Find the solution. If you have some valid solution, then you can take it as solution. So if you have one valid solution, then the number of solution is 1. If you have two valid solution, then the number of solution 2. And in this way you can do it. I'm not doing it. I'm just saying you the steps. We have logarithmic, right? So you can apply the division formula. I mean ln of x square by 4 into x minus 1. Then you can cancel the logarithmic from both the side. I mean with some specific step. You just have to take exponential and so on. Then you can cancel the logarithmic. Then just solve. You will again get a quadratic equation. Solve the quadratic equation. Then check at that point. If you suppose if you can find some two solution from a quadratic equation, right? But there may be some point at which the logarithmic is not defined. So you have to keep this in your mind that it should be solution of the quadratic equation, and this should satisfy, at least it should be defined. I mean, it should be member of the domain of the logarithmic function. If the solution equals to 0 or 1,
Simply, ma'am, number greater than 0.
number is greater than
Ma'am,
0, we cannot say. Number is less equals to 2 and greater equals to 0. It can be anything, 0, 1, 2, anything. Okay. We will find a quadratic equation. That means you can solve it, and you can find maximum, you can find two real solution, right? But again, you have to check whether the logarithmic function is defined at that solution or not. If suppose for say 0 is one of the solution, okay, then the first logarithmic function will not be defined, right? So you cannot take this. If 1 is the solution, then you cannot take this because the logarithmic function will not be defined again. So if there is 2 or 3 or anything, then you can take it as solution. So you have to keep in your mind that it should be solution of the quadratic equation, and it should be member of the domain of the logarithmic function. Okay.
Ma'am, can I talk?
Yeah, sure.
Ma'am, in fourth question, I'm getting only one solution. Like if we solve the whole equation, we'll be receiving a quadratic equation.
Which one?
Third question. Sorry. Yeah, third
Okay,
question.
that means this one, right?
Yes, ma'am. The same. Yeah. If we solve that, like if we do that, x square by 4 times x minus 1 equal to 1 we'll be getting. If we simplify that, we'll get x square minus 4x plus
Wait,
4
wait,
as
wait.
a quad.
Okay.
Okay.
Let me do it step by step. Okay. So we can write it as ln x square by 4 into x minus 1, right?
Yes,
minus 1, and this will be equals to 1, right? So we can take it as x square 4 x minus 1 equals to e power 1, right? Which is equals to e. So x square will be 4e x minus e, right? So we will get minus 4ex plus 4e equals 0, right?
Yes, ma'am.
Then you can solve it. Then just follow the Sridhar Acharya rule. So 4e.
Sorry, ma'am. I got it, ma'am. No need to do it. I did not square it with e. I just did 4x square minus 4x. That.
Okay.
Yeah. I took it as log. Yes, ma'am. Now clear.
Okay. Okay. So I guess you can now solve it, right? So the answer is 2, I can see.
2.
That
Yes,
means
ma'am.
that, we will find some point at which the logarithmic function will be defined to. Okay. That
Yes,
means
ma'am.
it will not be 0 and 1.
Yes, ma'am. Ma'am, a small silly doubt. If you go to the first question in this, previously I was talking about it. Yeah, if I substitute a equal to 1 by 2 and m equal to 2, then I'm getting option B and option C, ma'am. Both answers.
A equals to
1 by 2 and m
that
equal to
means
2.
log 1 by 2 and m equals to 2. That means 2 square.
Yes, ma'am.
Okay.
I'm getting
So
B and C, ma'am.
B and C. Okay, so 1 by 2. So you can write it as minus log
Minus 2, ma'am, answer.
2 squared. So minus 2 log 2, which is minus 2. And if we put here, 2 log 2 half. Okay, so this is again minus 2. Okay, so here for a specific value you can find, but in general, can you conclude it? I mean,
No, ma'am. No, ma'am. No, it's
like
not
if you
coming.
want to
Yeah,
conclude it for I mean, for this range, that means you have to conclude it for general cases. I mean, not for a specific value. Okay.
okay, ma'am. Yeah, even I got surprised. I just did it as a fluke. I
No,
just took
you
some
can
values.
find you can find some for some specific values, but if you are concluding it as a result, I mean in general, then you can like it should be true for all the values in the domain. Okay.
Yes, ma'am. Yes, ma'am. Nah,
Yeah.
no problem. No issues. Even I thought the same, and I just left it.
Yeah. Okay. So any other doubts in 6.5, 6, 7, 8, and so on? Yes. 6.5.
Question 1 is, ma'am, like simple, ma'am, it's but look complicated. Question 1.
Question 1. Okay, for question 1, you have a formula. Log n, float function of log n plus 1. Just put it. That's it. N is the number, okay? So float function of log n plus 1.
1.
This is the formula. Yeah, just apply the formula. This is nothing. Just have to apply the formula.
Okay.
6.7 and 6.6. Any doubt?
6.6 second question, ma'am.
Okay. So what is the problem?
1 minute, ma'am. I'm solving. I forgot what was my doubt.
Okay, so the number of solution is 0. So again, you have to do the same thing. I mean, just solve the equation. You know the formulas. Just apply the formula. This will be 2 cube x cube minus 1 equals to log 2x minus 1. Okay, this 3 you can take here as 1 by 3. Then just multiply this 3 here. Okay. Then it will be log 2 x3 minus 1 minus, you then have 3 here, then you can take the 3 as power, right? These steps are I'm not doing with like
Yes, ma'am. No,
by
it's
step
not.
because yeah. So you are all like comfortable with them, I think.
Yes, ma'am.
X cube minus 1 by x minus 1 whole cube, right? This is equals to 0. That means this term will be equals to 1, right?
Yes, ma'am.
Now you can easily solve it, right? So if it is 1,
X cube minus 1
that
equal to
means
x minus
x
1 whole
cube
cube.
minus
Somewhere I'm
1
getting doubt.
equals to, yeah, x minus 1 whole cube. Okay. Now you can break it. So this will be x cube minus 3x squared plus 3x plus 1 minus 1. Right? This is the right formula, right? I'm not sure. I'm asking you. Is the formula right?
Even I'm not sure, ma'am. Sorry.
Okay, so I think this is the formula. So we can cancel this two term. Then we will get minus 3x squared plus 3x equals to 0, right? Then take 3x common, then we will get 1 minus x equals to 0. So from here, we will get x equals to 0 or 1, right? Right?
Yes, ma'am.
So these are the
Yes, ma'am.
solution. But if we take x equals to 0 or 1, is it defined then? Logarithmic 2 of x minus 1. Then
No,
we
ma'am,
will
it's
get,
not coming in the domain. Okay, okay.
yeah,
Yes,
log
ma'am.
of 0 and log of minus 1, right? So it is not defined, right? That is what we cannot take it as a solution. Is it clear?
Yes, ma'am. Yes, ma'am.
Okay. Is it clear to all of you?
Yes.
Okay. 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 So, any other doubts? Activity
6.7,
or
second and third, ma'am. Second and third of 6.7.
okay. So, what is the problem in second question?
Ma'am, I'm not like very perfect in greatest integer function. I'm a bit inferior
Greatest
to it.
integer function is your float function, right? So, I mean, if you have something in this interval, suppose 0 to 1, okay, so then you have to take the value as 0. The greatest integer function which is less than or equal to the number x. Okay. So if we take this, I mean x minus box x, this will be always less than 1, right? And greater
Yes, ma'am.
than 0. Right? This is always greater equals to 0. Sorry, greater equals to 0. If the point is some integer point, then this is greater equals to 0, right? I mean, this is equals to 0 at integer point. But if it is not integer, then it is greater than 0 and less than 1. So
Yes,
it is
ma'am.
fine.
Ma'am, it gives fractional part of the x, right?
Yeah. We can denote it with the x
Yes, ma'am.
inside
Braces.
the
Yes. Yes, ma'am.
yeah, this is called the fractional part. So this is always greater equals to 0 and less than 1. So now you have a logarithmic function with this this type of thing. So here we cannot define when the value is 0, right? And we know when x is integer, then only the value will be 0. I mean, the fractional part will be 0, right?
Yes, ma'am.
So we just have to solve this problem. That means we will not consider the integer values. Okay. So if we not consider the integer values, then we will find something greater than 0, less than 1. This fractional part. So in this portion, the logarithmic function is defined, right? So domain will be real line minus the integer. Is it clear?
Okay. Yes, ma'am.
Yeah, at the integer point, always we will get some 0. So at 0, logarithmic is not defined, so we will exclude the integer points. So the domain now become r minus, that means the real line minus the integer. Okay. So
Yes, ma'am.
integer point is also infinite. And if we exclude integer points from the real line, then the excluded portion is also infinite. So option 1 and 2 are true. Okay.
One is not true, ma'am, in the answers.
No,
Option.
What?
Oh,
One
yeah.
should be true.
Sorry.
Yeah, this is
Yeah.
true, right? It should be true. And if we just
Also as
exclude
a
the domain,
finite number of
yeah.
asymptotes. Yes.
Yeah. So
Ma'am,
if
third
you
one is
exclude,
also because it has many vertical asymptotes on integers.
yeah. So whenever x will be tending to some integer point a, then this portion will be tending to 0, right? This is not, we are not including integer point, but we can take something tending to integer point, right? Just for 1, we can take x tending to 1, right? From the negative side, x tending to 1 from the positive side, right? Similarly, x tending to 2 from the negative side. Then this portion, this fraction, rational part will be tending to 0, right? Is it clear?
Yes, ma'am. Yes, ma'am. Ma'am, may I know what is invertible function definition?
Invertible function means inverse exists. That means a bijective function.
Okay.
Yeah. So bijective function, bijective function and invertible function are same. So
Okay, ma'am.
yeah,
Yes, ma'am. I know,
that
ma'am.
is why so the third option is also correct, right? Because for any integer point, you can find something tending to 0, hence the logarithm function will be again tending to minus infinity, right? So we'll find this type of thing every time. This type of thing. Okay.
Yes,
This
ma'am.
will be something in periodic type of thing, which will be tending to 0, tending to minus infinity for every integer points. Okay. So there will be infinite number of vertical asymptotes. Okay. Now invertible thing and range you can check, right?
Yes, ma'am. Done, ma'am. With the question, yeah, you can move on to the next question. Third question.
Yeah. So what is the, you have to check actually each options, whether it is satisfying or not. So did you check
Then
it?
yes, ma'am. Then I got the answer. Like I'm thinking, how do you do with without checking options?
No. You have to check all the options actually.
Okay. Then no,
Okay.
not required, ma'am. I thought, is there any some sort of
So right
mathematical way?
now, yeah, then maybe I can try. Maybe I can try. So, you can write it as logarithmic x2. This is as 2 cube, right? So 3 logarithmic y2. Okay. Then maybe we can write it as log.
Ma'am, how did you write x
Hmm.
square, ma'am? Or is it x log x
No,
base?
this is not x square.
Okay.
Log 2x plus 3 by log 2y, right? This step we can do equals to 0. So then,
Divide the base, common base.
yeah. Then it will be, I think, so log 2y plus 3 log 2x equals to 0, right? So log 2y x cube equals to 0. So y x cube equals to 2.0, that means 1. This is the conclusion, no?
Yes, ma'am.
This is the answer, right?
Yes,
Yeah,
ma'am.
you can do something, this type of observation. Just apply the formulas, okay? Then you can get.
Yes, ma'am.
The states are clear, no?
Yes, ma'am. No doubt in the step. Not even one. You have taken LCM, right, ma'am? In that step, which you have taken it to 0.
Yeah, just cross
Okay, ma'am.
multiplication.
Okay,
Yeah,
ma'am. Yes,
just
ma'am.
take the
Done, ma'am.
LCM. So I guess we have covered all the activity questions. So in practice assignment, do you have any doubt? If you have any doubt other than this assignment solution, then also we can try to solve it. So you can share it in the chat box, or you can just ask, just say the question. I will try to solve it.
Ma'am, could you solve Arun sir's question, like the previous question, if no one has any doubt in practice assignment? Like we have a lot of time, right?
Okay, I can check it.
Yeah, how do we solve the first one? B is greater than 0.
Okay, so for this, you just have to do similar type of thing. I mean, just take 1 by first logarithmic thing and second. Then you will get the base as B for both the cases. Then try to apply the multiplication rule and the divide rule. Then just try to get a quadratic or some like well-known equation, quadratic or cubic type of thing. Then just yeah, using this type of thing, you can solve it. Even if you are facing some difficulty, there are recorded version for all the problem practice assignment solution. These are available in the official YouTube channel too. Okay, so you can go through it if you are facing difficulty.
Ma'am, I have doubt in practice assignment question number 3.
Question number?
Yes.
Question number?
Ma'am, take
6.
6.
This one.
Ma'am, 6th one.
5th. This one.
Yes, ma'am. Ma'am, here why option 3rd is wrong?
Option 3rd.
Option 3rd is why correct? How we find out it is correct?
Okay, so the hint is again composition of two 1 1 function is 1 1. You have to check whether the both the function are 1 1 in the domain or not, in the given domain or not. Okay. You have two function. The first function is logarithmic. You know that logarithmic function is 1 1. And the second function is the x squared plus x plus 1. Okay. Just check whether in the domain, I mean in the interval minus 0.5 to infinity, in this interval, whether this function is 1 1 or not. If it is 1 1, then composition of two function is 1 1. So you can conclude about it. Okay.
And in question number 3rd, how option 2 is wrong?
Question number 3rd.
Yes, ma'am.
Okay, so again, if the base is between 0 to 1, then the function is decreasing function, right? Decreasing function means when x is less than 1, logarithmic bx should be greater than logarithmic bx1, which is 0. So this should be greater than 0 because the function is decreasing in this interval.
और 5x plus 9 divided by 2x का रेंज कैसे निकालेंगे?
What? Can you repeat?
5x plus 9.
5x plus 9.
Yes, ma'am.
In which question?
Ma'am, this first option, can you like please describe how it's rational or irrational? Like there are very big numbers also. They say that it's rational
Yeah,
or
so this is if this type of questions is there, for this you have just one common method. If it is rational, just consider it as rational. Then you just have to write some contradiction. Okay. So if it is rational, then you can write it as in p by q form, right?
mm-hmm.
Like
Yes.
your p, q are integer and q is not equals to 0, right? So
Yes,
then
ma'am.
you can take 5 here, right? So this will be cancel out. Then we will get 2 equals 5 power p over q, right? So 2 power q will be 5 power p, correct? So from this, you can imply that 2 divides 5, but this is not true, right? 2
Yes,
doesn't
ma'am.
divide 5. So this type of step you can always do. Okay?
Okay, thank you, ma'am. Like it's very good step.
Yeah. These are really interesting, and these are just small steps. You can observe it.
Ma'am, could you tell where can we find the practice assignment videos, ma'am? Like, I'm not able
Uh,
to,
all the videos are available in the playlist, and
like,
the
I think
official
it is
Blender
unlisted,
channel.
ma'am. Where are those? Like, could you just tell me, in the website
Yeah,
or?
you can go to the channel official ITMBS degree channel. Just go to playlist. Then you can find a playlist, namely maybe assignment solution. Then you can see the titles. There are, I mean, the titles and question numbers are mentioned there.
Is it possible to cluster them together?
What?
Is it possible to cluster them under one topic or something? Because I think since many people are solving these questions, and it
Mhm.
doesn't come under the one playlist or something, it's quite distributed.
No. This is in one playlist. I mean, these are not distributed.
Because when I try to
Uh,
go with the playlist, I don't see all the questions in one place. At least I don't see it. I don't know about others.
okay, let me check once. But I checked it last time. Whatever I remind, it should be in the same playlist. Let me check. Okay, so just go to the playlist. Then you can find there are a portion called like Maths 1 assignment solution videos. Can you check it?
That's it.
Then you can find all the solution questions.
No,
Okay, let
ma'am,
me
it's
share
not
the link.
showing. Once
Okay,
I
could
okay,
just
you?
let me.
shared. Wait, just a second. I just shared the YouTube link.
Yeah, I
Can
I
shared.
just
directly.
shared the playlist.
Yeah, I'm also
I just
shared.
shared the playlist. So, okay,
I
I
also
think
shared
I
it.
didn't share to you, Arun. Can you share it to everyone?
Yeah, he
Yeah,
shared it.
yeah, everyone only shared. So maybe it's I think for myself is as a playlist. I think other things are individual video. I think.
No. This should be in the playlist. I mean, we are adding this in the same
Yeah. So
playlist.
my link I just copied from the playlist.
Yeah. So we
Whatever,
can
Arun, I
find.
shared it. Arun, I shared it. Which one was she was saying? But you shared one that is common, whichever the Zoom meeting lectures. Actually, this is what I shared is what she mentioning. That is one.
Okay. I
You
think.
can just open it and assignment solutions videos and what she
Yeah.
was
I just
mentioning.
shared it.
Oh.
That one only I shared in the group. Just check it.
Yeah. This is the correct link.
Same list.
So you can
Yeah.
go through this link, and all the solutions are there in one single playlist. So you can find them. Okay.
But till week 7, it's I think done.
Yeah.
Right?
Till week 7. Week
Okay.
8 and all we will add them in the playlist very soon.
So PQ means practice questions or practice as in question.
Yeah. PQ means practice question.
Practice as
AQ means your activity
activity
questions,
questions.
and solve with us are also there. Okay.
Okay. And what is the situation? That's a good initiative.
Yeah. So you can find all the solution for activity question. I solved the selected problems. Actually,
Mm-hmm.
almost all the problem, but mainly the selected problem, which you can have like doubt with. And practice assignments are completely covered, and solve with us also completely covered. Okay, so you can
Very,
find all the solution recorded version there.
very good. That is commendable. Thank you.
Yeah.
I have a question. Like now that already they have released week 8, so invariably after week 8, they will next Friday they will be releasing week 9, and then it will be. Is it even before the? I mean, if it's true, we will have week 10 also to the extent to be released. Is it?
Now in quiz 2, you have up to week 8, whatever I know. Four,
Yeah.
5, 6, 8. 4,
Yeah.
5, no, sorry,
5
5,
to
6,
8.
7.
5 to 8. 5 to 8.
Yeah, 5 to 8. Yeah.
But weekly they'll release. That is not a big deal, right? That will be there in your playlist.
Yeah.
They'll release, just
Yeah.
release weekly.
All the things like your problem solutions and your Hindi recordings too, all will be available in time. So you can go through it with your time and actually.
And I would like to say this. Somebody was asking this. Arun only asking WhatsApp group. Are you also mentioning? I just created a WhatsApp group, and Kishore also was asking me to create, and we created it. Whoever genuinely asking for a doubt and sharing thoughts, you
Yeah,
can
yeah.
join. We can join.
I will always suggest you to join the WhatsApp group, your common group, and share all of your doubt to each
Ma'am,
other so that you can get connected and you can solve more problem together. So it is really a good initiative.
But the thing is, what happened? The batch would be different. Last batch, whatever we were in the group, and that batch student took some other question, some other subject, and we cannot share our doubts or something. So that every batch I like to create. We would like to create. Otherwise, it won't work out.
Yeah. You have to create it for every batch. Like you
Every
have to
batch,
take the initiative and you have to create
yeah.
like this type of
It's waste
WhatsApp
of
group
time.
of.
I joined many group, and right now I'm just exiting it. It's inappropriate to me.
No. For your group,
Correct.
you just create a group. Like because you are joining so many
Yeah.
group, then I don't think it will be helpful. So just create group with your batch.
Yeah, I just
Whoever is
shared this
facing the same
WhatsApp link to everybody. Whoever
yeah, you can
interested
share.
can join. Arun, you can also join. Thank you.
Yeah, sure, sure. So, madam, this link is shared. Actually, this separate one. Actually, this is not our that live whatever our training session videos, right? This is separate. Huh?
No, no.
Whatever you
This
It's
is
shared.
separate.
separate.
Okay.
This is separate. This is
It,
just like separately made videos. So
okay.
yeah. These are the fresh
And
videos.
in addition to that, Vishal also having one set of that whatever the TA session videos that is separate, right? That is separate.
Yeah. There are TA sessions also, but TA sessions videos are maybe recorded and you can find them in different
There,
YouTube channels. Maybe they
yeah,
are
yeah,
not available in the
yeah. The
official.
consolidated Excel they provided actually. They're
Yeah,
sharing that
yeah.
history. Yeah.
Yes,
Okay.
yes, yes.
This only video what you shared. It is only related to the so all problem related
Solve,
solutions.
yeah. AQ, PQ, and solve with us.
Okay.
Just that.
Okay. Thank you. Thank you.
Yeah. These are just for your.
Please once more. I just lost it.
And 1/x is always
Sorry,
on
this is actually
division.
out of question. Just now he hello. Can you hear me?
Yeah.
Yeah. Because just now Arun raised a topic about the TA links. Yesterday the session was cancelled without any prior intimation, and we were waiting for a long time. And this is almost like the fourth or fifth time this is happening, that sessions are being cancelled without any prior intimation.
I have talked to Vishal about it, but maybe there was some emergency. I'm not so sure about it.
Because I was waiting for a long time, and people were there, then one after other everybody drifted away. So even I came back and logged in after some time, and none of them were there. So I thought maybe they will send a mail, but they haven't even sent any mail of any compensation session or something. I don't know what is the plan. So
Okay, so
and this
I'm
is
not
actually
really
happening for
very sure about it. I mean, I talked to Vishal about it, but maybe I have to talk to him about it again. So,
so as I told you, this fourth time or fifth time this happened.
better if you are facing this type of thing repeatedly, you can ask Vishal also directly about this type of inconvenience.
Because I thought it's a TA session, so I just asked DA thing whether they will they provide any this thing intimation. They said no, you actually discuss in Discord. So nowadays I think whatever we ask in support for anything, now they say that you ask in Discord invariably. That's what I could see, that whatever the topic I could see that. I'm surprised.
Okay, so if you are facing this type of thing regularly, I think you can ask in his session too. I mean, I will also talk to him about it.
Yeah.
So, Yeah.
Because like we plan and come for the session, and
Yeah, I can understand. But
yes, I want to let you know about this.
yeah. Okay, so let us focus on the problems. Yes.
Just share the link
One
once, the
by
YouTube videos. I just lost it.
Okay,
ma'am,
I'm
one by
sharing it again. Yeah, someone is asking something, some problem. Yeah.
ma'am, 1/x is always a decreasing function.
Can you repeat again?
And 1/x is always a decreasing function or increasing function.
1 by x. So it's depend on the value. It's not decreasing, it's not increasing. But if you restrict the domain, then it will be decreasing or increasing accordingly. I mean, what is the graph of 1 by x? Something like that, right?
Then actually,
Something like that. So in some domain it is decreasing, in some domain it is increasing. So yeah.
ma'am, in activity question 5.2, it says range of the x is
I cannot
domain.
hear you. Can you be little louder?
Ma'am, in activity question 5.2, domain of the 1 by x is real number except 0. So this function is increasing or decreasing.
5.2. So all of you are done with 6. Like you don't have any problem with week 6, then I can look for another weeks.
I think when we actually try to reload the practice assignment, we will get new problems.
Yeah, you can go through them. Yeah.
Once you submit the answer and reload, you will get new problems.
Okay, so yeah, which question you are talking about?
Activity 5.2, question number 3.
This one? Five point two, question number 4. This one?
And question third. And question number 6, I think it is.
Question number? Can you be little louder? I cannot hear you. What are you saying?
And activity 5.2, question number 3 it is.
Question number 3. You can
Activity
write it.
5.2.
You can write it on the chat box. I'm not clearly getting. Five point three, question number 3. Yeah, this one. So what is the
And this
problem?
is activity 5.3. And this is activity number 5.3.
Yeah, you are saying 5.2, no?
Yes, ma'am.
Okay, sorry, this is 5.3. This one.
Yes, ma'am.
This one?
This last
Okay.
option, 1 by increasing or decreasing.
I just told you, whenever you have to find the function is increasing or decreasing, just calculate the derivative. Okay. So it is neither increasing nor decreasing 1 by x graphically. But also you can calculate the derivative whenever you have f dash x will be minus 1 by x square. Right?
Yes, ma'am.
Okay. So if you take x greater than, it will be always less than 0, right? So it should be decreasing. I mean, wait. Okay, so this is not in the answer. I don't know why. Okay. Let us check the graph. Then I will again do it mathematically. So you can see the graph, right?
Yes, ma'am.
Okay. So if we take this as the domain, then you can see clearly the function is decreasing, right? If you take this
Yes,
as a
ma'am.
domain, then in this domain also the function is decreasing, right? But
Yes,
if you take the whole domain, and I mean this, okay, then just check at this point and at this point. So this value is clearly less than this value, right? 1,
yes, ma'am.
2. And this point is clearly less than this point, right?
Yes, ma'am.
So in this portion, whenever we are crossing 0, in this portion, this is not satisfying the decreasing statement, right?
Yes, ma'am.
Yeah. So the function is decreasing in minus infinity to 0. This is also decreasing in 0 to infinity. If it is the domain, then the function is decreasing. If it is the domain, then the function is decreasing. But if we take the domain as r minus 0, then we cannot say the function is decreasing, because for the negative side of 0 and for the positive side of 0, you can clearly see this is going towards minus infinity and this is going towards infinity. So in this portion, it is satisfying the definition for increasing function, right? So that is
Yes, ma'am.
why for this function, we cannot say this function as a decreasing function. Okay. Is it clear? I mean, the
Yes, ma'am.
problem?
In the
Yes,
practice
ma'am.
assignment,
Yes.
I thought like she
Yes,
wants to
ma'am. It
ask you
is
something.
clear.
Okay.
Uh,
Yeah, you can ask your question.
Regarding the practice assignment 6, the 8, 9, 10, I don't know whether you have the same questions. One about the seismologist, and I posted the 10 questions about the bulb in the chat. And the
Okay.
8 and 9, there are one is about bacteria, other is about seismologist. I don't know if you have the same question.
8. This is the
8
eighth
is,
question.
yeah, it's the same one, the seismologist.
9.
And yeah. Did you solve that? If you have solved it, I will go through the
Yeah,
video.
I solved it. Yeah.
Okay. Because I thought maybe it's a different question in your thing.
No. For practice assignment, I have covered all the problems, so you can go through the videos. Okay.
Yeah, sure.
Yeah. Also, if you're still facing any, like, I obviously suggest you to go through the videos. Then it may happen that after seeing the videos, even you are facing some difficulty, or there may be some doubt with the concept or anything. Then you can ask. Okay.
And just to comment the thing, so your sessions are only on Saturdays, or
No. This is not necessary. This is nothing like routine. This is just a random, like whenever who is free, they can
okay,
take the session.
okay. No, because like if I want to ask a doubt, I obviously I don't know whether you will come or whether Vishal will come or who will come for that. So I just want to know, like,
No, you
to
can
continue the
ask the doubt
conversation if
to
you want to.
anyone. No
Oh yeah.
problem. You can ask the doubt to anyone. You can mention if the session is taking Vishal or Samiksha. You can also mention that I have doubt with this thing. I have seen the recording. Still, I have doubt with this thing. Then you can ask them. Okay, so there is no problem in this.
So, ma'am, the syllabus of quiz 2 is from week 5 to week 8, not week
Week
1 to
5
week.
to week. No. Quiz 2 is week 5 to week 8. As
Uh,
yes.
and in term?
End term is all like from week 1 to week 11 maybe.
Okay, ma'am.
So week 5 to week 8 is your quiz 2 syllabus. So when is your quiz 2?
That's December 1st.
On 1st December, I think.
Okay, so you have time.
But the
But
end term, I
ma'am,
think
in term, yeah.
they give emphasis more on from 8 to 12, am I right? Is it not the case?
What?
For
8
the
to
end
12?
term,
No.
21st or 22nd December.
no. I meant to say for the end term, the weightage is given to 8 to 12 compared to the rest of the rest of the weeks, am I right?
Yes. So mainly the focus will be towards the graph theory maybe, but there will be at least one question from each week. Okay, so if you have more doubts, you can ask. Otherwise, you can leave. If you have doubt, you can ask. If not, if don't have any doubt, then you can leave. Okay, so I guess you don't have any doubt because all are silent. So maybe we can close this session. Okay?
Okay. For me, it's fine. I don't know.
Okay. So we can close this session for today. Then, okay. Good night, everyone.
Thank you. Thank you.
Night.
Yeah.